All right, so this is the first video in a really short series, Systems of Equations. It's really meant just kind of for very beginning algebra students. And so what I want you to understand after this is that you basically will understand what a system of equation, what a solution to a system of equations looks like by determining if a solution is viable. And so before we get into this, let's talk about what a system of equations is. A system of equations is basically two or more equations with the corresponding number of variables. So if I have two equations here, I'm going to have two variables, x and y. If I had three equations, I'd probably have x, y, and z, or x, y, and z. And basically, that comprises the system. And a solution of that system is where these lines, or where, in this case, where these lines intersect each other. So where y equals 2x plus 1, where that line, and where this line over here, y equals negative x plus 4, where those two lines cross is a solution. And so that's basically this first point here. And if you're finding a solution, that's equivalent to determining where those lines intersect. And the coordinates of that point down here in point 2 is the solution for both equations. Or in other words, that x and the y value of the point where those two lines intersect would work in both equations. So how would you go about determining if a given point is indeed a solution for two equations? One way is to graph both the equations and see if they intersect at the given point. The other way is to plug in the coordinates of the given point into the x and y values of both equations and see if it works. See if you get true statements at the end. Let's do a quick example to make this all clearer, because so far it's been maybe a little confusing. So we have our two equations, 2x plus 1 and negative x plus 4, and our two functions here. And the question is 1, 3 a solution? So is the point 1, 3 a solution? And I'm going to graph that point 1, 3 in the color black here. And I'm going to graph this first equation in red and the second equation in blue, and we'll see where they intersect. If they intersect at the point 1, 3, then we know it is a solution. Okay, so y equals 2x plus 1. That slope of this equation is 2. And I know 2 is the same thing as 2 over 1, and that's rise over run. And I know the y-intercept is at 0, 1. So I'll put that down. Okay, so I'm going to go up 2 every time I go over. So up 2 over 1. Okay, so that line hits that point. Up 2 over 1, up 2 over 1. So again, I'm graphing the y equals 2x plus 1. And instead of doing you might be wondering what I'm doing here. Instead of doing a table of x and y points, I'm just using the slope and the y-intercept to graph them because they're already solved for y. Sorry about my lack of straight lines here. I should probably start drawing lines with the computer instead of my freehand here. Okay, let me do the second one in blue here. Here the slope is negative 1. That's a negative rise over a run value. And my y-intercept's at 0, 4. And so this means every time I go over to the right, I'm going to go down 1. And you can see right off the bat here that both of these lines do indeed intersect at the given point. And so what that means is, I'm going to graph this using a line here, because a little better at doing that than I am freehand. Okay, I'm slightly off there, but you get the point. The point is that both of these lines intersect at the point 1, 3, at this point right here. And because they both intersect at that point, we know that 1, 3 is a solution. So that's the whole point of this. Where both of those lines run into each other, where they intersect, that's what we're looking for when someone asks you what's the solution for this system. But there was another way back here that I mentioned we could go about this, to plug in the coordinates of the given points and see if it works. So let's do that real quick. Let's determine whether or not it's a solution in more of an algebraic way or more of a calculation way instead of graphing them. So let's pretend you didn't feel like graphing the lines to see if they intersected where it said, and you just wanted to tell. Well, if you take 1, 3 and you plug it in, okay, so in this case the y is 3. So I insert 3 for y and 1 for x. And I can do the same over here. If you end up with true statements in both equations, then we know that this point 1, 3 is a solution. And as you can see quickly, as we simplify these, you get two true statements. So that's another way to say, okay, this is definitely a solution for both equations. Okay, like I said, this is an introduction, so quick recap of a solution for a system is where they intersect, or a point at which makes both equations true. And we're going to look at 3 methods for solving these. We're going to look at the graphing method, which we've kind of touched on already today, the substitution method, which we haven't done much of at all, and the addition and elimination method, which we haven't touched on at all. And so there's going to be 3 more short videos giving you one example for each, and I hope you find this helpful.